Assalamualaikum and hi everyone, this is Tata Shazira. In this video, we are going to be deriving the false position formula. Assume we have a curve fx within the interval a and b here, and if we have a secant line from that point to this point, then we can see that, okay, and we denote the intersection point here to be C. Okay, now if we form a rectangle, okay, then we can see the following. Okay, so we have the point A, C, and B, and we know that the point here is read as AFA, and this point here is BFB. Now, we can see that the slope, okay, here is equal to this slope. Okay, so it means we have M1 equals to M2. Okay, and okay, now the formula to get the slope for M1 is given by 0 minus FA over C minus A, okay, which is equal to the slope M2, which can be obtained by FB minus FA over B minus A. Okay, and with very simple algebraic manipulation, we somehow can form the formula for the C. Okay, so first of all, we may want to have this form, B minus A. Okay, in fact, we have negative here, negative B minus A times FA equals to C minus A FB minus FA. Okay, and you can work out on the algebraic manipulation to show that C is finally AFB minus BFA over FB minus FA. Okay, so this is the false position formula. Okay, now try on your own, okay, from here to here. Okay, work out on the algebraic manipulation and see whether you can get the formula for C, which is the false position formula. Okay, very simple derivation. The algorithm for the false position method is very much similar to the bisection method, except for this formula for the C. Okay, in the bisection method, C is just the midpoint formula. Okay, but for the false position, we have this formula. The rest of the algorithm basically follows what we have in the bisection method before. Okay, so for each iteration, we compute the C by using this formula, and after that, we need to compute FA and FC and see whether we have one of the following condition. FA times FC equal to 0, then we stop the iteration immediately and take our final answer to be the latest C that we have in our calculation. And if FA times FC is negative, okay, less than 0, then in the next iteration, B need to be changed. Okay, so it means with this condition, we actually consider the left section. Okay, and if FA times FC is a positive number, positive value, okay, greater than 0, then in the next iteration, A need to be changed, B remains. This is where we actually consider the right interval or the right section to proceed with our next iteration. Okay, so we repeat the process, step 2 and 3, until we satisfy any of these stopping condition, or we need to follow what has been specified in the questions. Okay, FC equal to 0, or it can be the absolute of FC is less than the given epsilon, or the absolute of B minus A less than epsilon. Okay, and don't forget to write down our final answer, the root for x star here to be approximated to the latest C that we have in our calculation. Okay, all right.